Okay, moving on to number 5. We've got the first 5 terms of an arithmetic sequence, 2, 6, 10, 14, 18. We need to write down the 6th number. I think it's pretty apparent what's happening is that we're going up by 4 each time, and so the next number in the sequence must be 22. We need to calculate the 200th term, so that means that we're looking for the 200th term, U200. Remember that un is equal to u1 plus n minus 1d. In our case then u200 will equal u1, which we can see as 2, plus n, which is the subscript, so 200 minus 1, or you can just write down 199 because you know it's 1 less, times d. And we can see that the common difference, the thing that we're adding every single time, is positive 4. And so it's multiplying a 4. And it doesn't say to it does say to calculate. So I guess we need to figure out what we get. 2 plus 199 times 4. And I didn't bother using parentheses because I know that my multiplication is going to happen first. That's exactly what should occur. And I get 798. And then it says find the sum of the first 90 terms. Remember that in an arithmetic sequence, okay, I forgot, so you should always circle that word. Sn is going to be equal to n over 2 times, we've got a choice of formulas. In this situation we do not have the 90th term, so let's use the formula that has the d in it, 2u1 plus n minus 1d. So let's substitute 90. We're looking at the 90th term, so n is 90, 2 times u1, n minus 1 is 90 minus 1, or 89d, which was 4. Let's put this into the calculator. 90 over 2, 90 over 2, times, open parentheses, 2 times 2, plus 89 times 4. And we get 16,200. Okay, let's move on then to number 6. The number of terms in this sequence. Now let's just analyze the sequence first. Is it arithmetic? Well, you'll quickly see that the difference between the first 2 terms and the difference, remember we write them in reverse order, the difference between the next pair of terms are different. So it's clearly not arithmetic. Let's see if it's geometric. 64 over 128, that equals 1/2. 32 over 64, that equals 1/2. 16 over 32, that equals 1/2. We can see that what we have here is a common ratio, and therefore it's a geometric sequence. Now the question didn't ask us to show that it was a geometric sequence, so you don't need to be quite so formal about this work. But I don't want people to be thinking, oh, divided by 2, divided by 2, divided by 2. Well, sure, that is what makes it a geometric sequence, but I think you're better off doing something like this ratio work, so that you can see that your value of r, the thing that we are multiplying by each time, is 1/2, or if you prefer, 0.5. Now in part A says determine the number of terms in this sequence. It does tell us that we get all the way to 1 over 512. This is our nth term. I don't know if it's my 7th term, my 12th term, my 15th term. That is my nth term, and I'm trying to figure out what is the value of n, what is the number of terms. So I know that in general in a geometric sequence un is equal to u1 times r to the n minus 1. Well, let's substitute what we know. We know that un is 1 over 512. We know that u1, the first term, is 128. And we know that our r is 0.5. And so let's put this to the power of n minus 1, where I am trying to solve for that value of n. Alright, I'm going to put this into the calculator. So I guess I could say 1. Now I'm expecting n to be an integer here. So maybe a table would be the best approach. So let's go into y1, and I'm going to put 1 over 512, my left-hand side of the equation. And in my second one, I'm going to put my right hand side, 128 times 0.5 to the power of x minus 1. And now then, as I look at my table, I'm going to look to see where is my y1 value. This is the decimal equivalent of 1 over 512. Where is it equal to my right-hand side of the equation, the y2 value? So let's scroll down a little bit and see where they become the same. Not quite yet, but we're getting close. And we finally hit it where? There. Okay. Alright, we can see then that on the 16th row, it isn't quite small enough. It's only when it gets to the 17th row is it finally the same. So, in order to show my work that I've used a table to solve this particular equation, I need to include my 16th row, where it wasn't quite enough, and my 17th row, where I finally was enough. And so when I finally was enough, these things matched. Sorry, I'm a little scrunched in. I hope you can read this. 0.0195 on the 17th row. On the 16th row, we were only at 0.0. Oh, I've been skipping zeros, haven't I? Sorry, 0.00, 0.00, and 0.00. You know what I mean. And just above it, I'm 0.00391. And that's not quite small enough. It's only when I get to the 17th rows. Now, don't forget to actually answer the question. I can't just stick a table here and leave it up to the examiner to infer the answer. I've now got to interpret that, look, it was on the 17th row where I was finally equal. So n, number of terms, equals 17. Write down the answer. Now, the sum of these terms, so that implies that we're looking for the sum of all of these 17 terms. We know that in a geometric sequence, that our Sn is equal to u1 r minus r to the power of n over 1 minus r. So let's substitute. We have u1 is 128. We have 1 minus r, which is easily done in the calculator as 0.5, to the power of n, which we know is 17, all over 1 minus 0.5. So let's be careful using the calculator because of the parentheses in such a complicated expression. 128 is multiplying 1 minus 0.5 being raised to the power of 12. And now let's divide it by the bracketed expression. Just a second. 1 to the power of 12. Exit the exponent and now close the parentheses. Good. And divided by 1 minus 0.5. And we get an answer of 255.9375. Oh, it wasn't to the power of 12, was it? It was the power of 17. A clever thing I can do when I've made a mistake on just a single thing, instead of typing it all out again, you can bring back the previous entry on a calculator by pressing second enter. And that brings back everything you just typed, and now we can just go back and change the incorrect number to the power of 17, and now hit enter. 255.998, and we could always round that to 3 significant figures, 256. But always probably better to write down an answer with lots of decimals, and only in the very end round it to 3 significant figures. If you round any earlier than that, you're going to lose accuracy. And if you don't write down a nice long decimal number, you could be penalized in some questions. So I would always write down the big long rounded decimal before rounding. Number 7. The area of a fast-growing plant is measured at noon each day. On July 7, the area was 100 meters squared. So here's July 7, and we can see that we're at 100 meters squared. So we can see that this is a area versus time graph. For each day after July 7, our area appears to be increasing because, of course, it's a fast-growing plant. And so this implies then that we've got exponential growth, as you can see down here. every day the plant grew by 7.5%. We know that that means that we're adding 7.5% if I move the decimal twice to make it a decimal. And, well, there we go. There's the growth factor right there, demonstrating the amount that we're growing by each month. Whoops. No, sorry, each day. Okay, so yeah, now it says in part A, what does the graph represent when t is negative? So you'll note that on 7th of July, t was 0. So as t becomes greater than 0, that means that we're moving after the 7th of July. So what does it mean if t is less than 0, negative? That means that we're moving before the 7th of July. So what is the graph representing in this region where t is negative? Again, it's still representing the area covered by this plant, except that now it's the area covered by the plant on days prior to July 7, because time negative means that we are in the past or before t was equal to 0. So it just represents the area of plant in meters squared before July 7. Part B, use the graph to find the value of t when A, the area, is 178. Now I notice it takes me 10 little squares in order for me to move from 100 to 200. 178 must be just below the 8th square, and so I'm just going to trace across here. And what is the number of days? Looks to be about 7.5 days, doesn't it? Somewhere between 7 and 8. So I'm going to estimate the value of t to be 7.5 days. Part C, calculate the area covered by the plant at noon on the 28th of July. Now let's think about the 28th of July. From the 7th of July, how many days later is the 28th of July? 28 minus 7 implies that we have moved forward 21 days. So then if t equals 21, that is to say that the number of days after July 7, is 21 days to get us to the 28th of July, surely then we just need to substitute the t into our equation, which inconveniently got cut off partway through the line, it appears. Sorry if that showed up that way on your photocopy. But a is equal then to 100 times 1.075 being raised to the power of 21 days later. So 100 times 1.075. You'll notice that this is a growth factor because it's larger than 1. If you multiply by any number bigger than 1, it's going to get bigger, isn't it? And that's to the power of 21. 456.644. You notice I'm following my convention of writing down more decimals than I need first. And then I can always round it at the end to 457. And it says to calculate the area. Let's make sure we include the correct units. That's meters squared. Moving on to number 8. How many terms of the series are needed to exceed a sum of 450? So we are looking to exceed the sum. Exceed a sum. Let me think of this through again. How many terms are needed to exceed a sum of 450? So this is representing the sum. When is the sum going to be greater than 450? Okay. Now then let's observe this series then. I think you'll see pretty quickly that we're going up by 5 every time. That means that our d value is equal to 5, and it's an arithmetic sequence, or in this case an arithmetic series because we're adding them together. We can see that u1 is equal to 11, d is equal to 5, and we want to find out what n is. How many terms will it take in order to have a sum which is greater than 450? Now our sum of n terms, because I've been given the d value, let's use the d formula again. So n over 2 times 2u1 plus n minus 1d must be greater than 450. Whoops, I should have substituted in my u1 to be 11. And I should have substituted in my d value to be 5. So let's type this expression into the calculator. and find out when do we finally get a value bigger than 450. Now anytime that you're solving for an n, we know that n represents the number of terms. You can't have 6.5 terms in a sequence or series, so we expect n to be an element of the integers, right? Remember that z represented the integers. So if z is an integer, or even better yet, it's one of the positive integers, which we can express as the positive natural numbers as well, then it's probably better to use a table. So let's go into y equals, and I'm going to make my left-hand side is an x over 2, which is multiplying the bracketed expression of 2 times 11 plus x minus 1 times 5. And I suppose I could also make another table that says, another y value of the right-hand side, 450, like I did with my previous question of 1 over 512. But because 450 is already an integer, then I expect this value to show up on the table. So I'm not going to bother, and I'm just going to go straight to my table. Now, we'll notice straight away that we got a problem with the table. Or maybe we don't. Oh, we got a problem with the table. I don't see a 450. Oh, it says to exceed a sum of 450. Okay, so, sorry, I wasn't expecting to see 450 on the table. It's, yeah, it just has to be greater than. But I could use a table because my n values are, of course, going to be integers, and a table is perfect when you're dealing with integer values. We can see that when we were at 11, we were only at 396. On the 12th row, we were finally above 450 at 462. So let's just show what we've done. Okay, we set up a y1 value as our x over 2 times 22, 2 times 11, plus x minus 1 times 5. And then we created a table, so we've got an x and a y1. And when we were on the 11th row, we weren't quite big enough, but when we got to the 12th row, we finally were big enough. We were, I think that says 462. And so because we were bigger than 450 at that point, we can see that the n value that we're looking for is 12. So don't forget to actually answer the question at the end, having written your table. Therefore, n equals 12. Okay, it takes 12 terms to exceed a sum of 450. Number 9, let's look at these tuition fees for the first 3 years of high school. It tells us that they form a geometric sequence. We need to find the common ratio, r. We know that a ratio is found by taking a pair of terms and writing them in reverse order, so I'll write the second one and then the first one, and because it's geometric, I'm going to be dividing. And I could verify with the other pair of terms, 3,125 divided by the one in front of it. Let's calculate what each of these are. So 2,500 divided by 2,000 gives me 1.25, and 3,125 divided by 2,500 also gives me 1.25. So clearly it is a geometric sequence, and clearly the ratio has shown itself to be the same, 1.25. Part B. We need to calculate to the nearest dollar the total cost. Alright, important to be circling words like total, just like with arithmetic and geometric, because total shows us that in this case we're looking for a sum. And we're looking for the sum of the first 6 years, so we're looking for the sum of the first 6 years. So in general, remember, for a geometric sequence, you've got u1 times 1 minus r to the n over 1 minus r. And so we're looking for s6. And so our first term was, you can almost see it, 2,000. Our r value is 1.25. And the 1.25 is being raised to the power of n, which in our case is 6 years, over 1 minus the r value. Here we go. 2,000 multiplied by 1 minus 1.25 to the power of 6. Close the brackets, and now we're going to be dividing by the total denominator in brackets of 1 minus 1.25. And hit enter, and the total tuition will be rather staggering, $22,517. It does say to the nearest dollar, so this is one where they were very specific about what they wanted you to round to. It's another good expression to circle. So 22,500, and because of the 5-7 being bigger than just 50, it's obviously closer to $22,518.